All right. Hello, everyone. We are looking at 8.1, which is kind of the brief intro into confidence intervals. So we have a cute little cartoon to start off, and the TV says, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. And then Garfield thankfully thinks this guy never wrong, so he's the smartest weatherman ever. So if you give a range of what the weather's going to be like between those two numbers, it's obviously going to be somewhere in there. Um, so he's always right. And so we're going to be basically trying to use a range to estimate some things. And maybe we can get it a little bit more narrowed down than this large of a range today. All right. But put the first subsection, if you're in the book, is confidence intervals, the basics. So a question I like to ask with this is, how many countries do you think are in the world? And if you had to take a guess of just a number of how many countries, you might say I don't know, maybe 140. Maybe if you're in an AP history class, maybe you know this exact answer. But if you didn't, you'd probably guess maybe somewhere in the 140s, maybe less. Um, but you take a guess of it. And whatever that guess is, that is what we call our point estimator. And basically, a point estimator is a statistic that provides an estimate to the population parameter. In this case, it would be the population parameter would be the number of countries in the whole world, and we're estimating it at about 140. Um, so it's a single number. It's our best guess. Maybe we use some background information, um, some other ideas we might have. If we knew how many countries there were in Europe, for example, we might use that to kind of help us go from there. But it's just our best guess, and we really should have little confidence that it's exactly correct because it's just one number. And there could be 141 or 142 or maybe 160 or maybe 200. We're not quite sure. So it's just a best guess, and we don't want to have too much confidence in our guess there. All right. There's a nice little example of this kind of point estimator. Um, So I'm going to kind of go through it a little bit, but it says, identify the point estimator you would like to estimate the parameter in each of the following settings and calculate the value. So if we look at number one, says a quality control expert wanted to estimate the mean lifetime mu of AA batteries produced each hour at a factory. They select a random sample of 50 batteries during each hour of production and then drain them under conditions that mimic normal use. Here are the lifetimes in hours. And they have them there. So basically, if we're going to do a point estimate of it, we would probably take the sample mean, right? Because this is a quantitative data set. It's a bunch of numbers. Um, so we would probably take that. I'm trying to figure out where to put me is the best spot. Sorry about that. Um, and so if we did that, we could add up all those and divide by 50 and get a mean average lifetime of 16.718 hours. And again, this is just going to be a point estimate. And it's definitely not the true proportion because we only took a sample of 50 batteries, not the whole thing. So you could take the sample mean is one option. Maybe another option of a point estimate is a sample proportion or p hat, which we talked a lot about in chapter 7. And maybe the last thing, if you'd want to do, would be possibly taking the standard deviation, the sample standard deviation, as a point estimate and go from there. And basically, I just want to remind us that point estimates are a statistic. The notation matters. Okay, so we're not taking the population mean; we're taking a sample mean. So that's why I have to use x bar, I have to use p hat, and I have to use s sub x because notation does matter in this situation. Okay. The next subsection is called the idea of a confidence interval. So, what is a confidence interval, basically? So let's think back to that country idea. So to increase our confidence in how likely we were to get it right, we might use an interval instead of a point estimate. So when I said, "Oh, I bet there's 140 countries," a better estimate to say, "Well, there's between 0 and 500." All right, and that's definitely correct. Right? Maybe to be even more sure, you might say 0 to 1,000, and you'd be absolutely correct. There's 0 to 1,000 countries. So you are 100% confident you are right. All right. And although this is true, that's such a large range that it doesn't really help us pinpoint anything. If we were trying to figure out the true number of countries, 0 to 500 or 0 to 1,000 doesn't really help us all that much. So we want to make an interval more plausible. In this case, maybe you're like, well, I could list off 20 countries right now. Maybe you got Canada, US, Mexico, Cuba, you got the Dominican Republic, Honduras. I'm thinking all in North America and Central America right now. But maybe you can list off 20 right there. So you can bring up, instead of from zero, there's at least 20. And then you go, okay, there's maybe 20 to 500. And then maybe you can list a few more. Maybe you get that up between like 50 and 500. Um, and that might be able to help you bring it a little bit closer to a more plausible confidence interval. We'll talk about how to kind of make it even a little bit more with some statistic uses. All right. So a confidence interval, though, is just it's a given interval of plausible values for a parameter basis. Okay, so that's the definition we're going to use. It's plausible values, and plausible equals potential or likely values of the parameter, not necessarily guaranteed. Okay, so our confidence interval, I'll abbreviate CI pretty frequently as confidence interval. The way we find is we take a point estimate and we add and subtract an interval toward. Okay, and throughout this chapter, we'll kind of define what that interval is going to look like. But it's a point estimate plus or minus an interval. So imagine I said, hey, 140 is kind of my middle. I'm going to go to the right some and to the left a little bit also. Mm. And the big thing is the interval changes based on how confident we are or want to be. Okay, so for example, if I want to be 100% confident, I picked a super wide interval, 0 to 500. If I want to be less confident, maybe I only want to be 95% confident, then I might pull in the ends a little bit to be a little bit less confident, but I'm a lot closer into a range of what that number will actually be. The most common confidence level is 95%. All right. And so that interval we talked about, which is part of a confidence interval, is called the margin of error. Okay, so really our confidence interval is point estimate plus or minus the margin of error. Okay, and the margin of error is defined as it's of an estimate describes how, so the margin of error of an estimate describes how far at most we expect the estimate to vary from the true population value. Okay, so think about if I expect it to vary, let's say that I was at the middle was 140, I expect that to vary by 50. So my margin of error would be 50. So that means I'm anywhere from 90 to 210. Okay. So my margin of error is how far I expect the population parameter to kind of fall in there. A really common way we describe these margin of errors you might see are in political polls. So I think there's an example here coming up. But political polls are a very common way of use of margin of error, and they use just the word that they usually use is points. So you're like, oh, he's up 5 points. That means that, well, he's up 5 points, or what's the margin of error? It's 3 points. That means that it's within 3. So they don't usually use percentages. They'll use points. So if someone was polling at 55 points, they're really at 0.55. The other person might be at like 0.45 or maybe a little bit less if you have third-party candidates, with the margin of error of 0.1 per se. So how much they expect where the candidate really falls is in that margin of error. So a little bit more about this, the confidence level. So the confidence level gives an overall success rate of the method used to calculate the confidence interval. And that is the interval computed from the sample data will capture the true parameter value in C% of confidence. It will capture the true parameter value in C% of all possible samples when the conditions of inference are met. So we'll take a look at what that really means because it's kind of a choppy definition, I think. So here's kind of an example. So the Associated Press and the NORC, Center for Public Affairs Relations, recently asked a random sample of U.S. adults how much financial difficulty they would experience if they had to pay an unexpected bill of $1,000 right away. Overall, 65% responded respondents admitted they would have a little or a lot of difficulty. A summary of the study reported that 95% confidence interval for the proportion of U.S. adults who would admit to experiencing some financial difficulty is 0.63 to 0.687. That is, they are 95% confident that the interval from 0.613 to 0.687 captures the true proportion of all U.S. adults who would admit to experiencing some financial difficulty paying an unexpected bill of $1,000. So a lot of words right there. Basically, they do a sample, find out the overall. In this sample, 65% of them would say that they have a difficulty. They create a confidence interval, so they use 0.65 as our point estimate. They create a margin of error and go plus and minus to get this range of 0.613 to 0.687. And they're saying that they are 95% confident that this interval captures the true proportion of people who could not pay for it. All right. When we do calculate our confidence intervals, we always interpret them the exact same way. So similar how we've been building up um, some ways how we would respond to a free response problem about a normal distribution. If I'm ever interpreting a confidence interval, which I usually will, we are going to use this statement right here. We are blank, whatever the confidence we are 95% confident that the interval from blank to blank captures the blank. And that last blank is the parameter in context. Okay, so another example would be down here. So that you kind of see that here they are 95% confident, blah, blah, blah. Range to range or interval to the interval captures and then here is the parameter in context, the true proportion of all U.S. adults who would admit to experiencing some financial difficulty paying an unexpected bill of $1,000 right away. All right. Here's another example. We are 95% confident that the interval from 0.28 to 0.32 captures the true proportion of people who would vote for Proposition X. So that's a different example, but it's just kind of another one, just so you kind of see a separate example. Continuing on in that subsection of the idea of a confidence interval, this is a big AP exam tip that I thought I'd highlight, specifically the highlighted part. When interpreting a confidence interval, make sure that you are describing the parameter and not the statistic. So you are 95% confident that the interval blank to captures the parameter, not the statistic, but the parameter. We already know what the statistic is. We used it as our point estimate, and that's our middle value. So our confidence interval will definitely capture the statistic because it's in the middle of it, but we are trying to capture the parameter in this case. So at here, you can kind of see a visual representation of a confidence interval. So you can see here's my point estimate, and I found my margin of error, so I went to the left and to the right that much. And so that's kind of a visual representation. If you want to see an actual one with numbers, you can say, this is from that example we just talked about. We are 95% confident. We did a 95% confidence interval for all U.S. adults who would experience some financial difficulty. We found that it was from between 0.613 to 0.687. So basically what they did is we had our point estimate. We took a sample, found 65% said that they would. That's our middle point right here. And then we plus or minus that margin of error. So we went to the left, to the right, 0.037. And that's kind of how we calculate our margin of error. So it is an interval. And be careful not to say it is a range, because remember, a range is a specific number. If we think about chapter 4 or 1 or 2, I kind of get all blurred with me. But when range is a number, it's the max minus the min. So we don't want to talk about ranges being a span of something. When we use range of something, we're really talking about the max minus the min. So in this case, we want to make sure we use the word interval instead of a range, just so we're a little bit more consistent with that language. Here's another example, kind of look at. So 2 weeks before a presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for candidate A or candidate B? based on the poll, 95% of confidence interval for the population parameter who favored candidate A is 0.48 to 0.54. Does interpret this confidence interval. So when we interpret a confidence interval, it's always that same sentence. We are 95% confident that the interval from 0.48 to 0.54 captures the true proportion of all registered voters who favor candidate A in the election. So this is what I'm going to highlight right here. Is that part of in context, and we're talking about the true proportion of the parameter. All right. Part B asked, what is the point estimate and what used to create the interval? That was used to create the interval. What's the margin of error? So the point estimate's right in the middle. So if you don't know the point estimate, you can find it by adding the two values together and taking the average and dividing by 2. You get the point estimate is 0.51. And then therefore the margin of error is from one end to the middle. So you can take the max minus the mid minus the point estimate to get that margin of error. So you can kind of see here, point estimate is the midpoint. The margin of error is the distance from the point estimate to the endpoint. And then third, based on this poll, a political reporter claims that the majority of registered voters favors candidate A. Use this confidence interval to evaluate his claim. So this is a very kind of a textbook definition, but it says, because there are plausible values of P less than or equal to 0.5 in our confidence interval, the interval does not give convincing evidence that a majority of registered voters would favor candidate A. So basically what this means is that in order to be certain that someone favors candidate A over B, they have to be more than 50%. They'd have to be 51, 52, 53, anything more than 50. Okay, our interval here goes from 0.48 to 0.54. So there's a chance that the true proportion is actually that favor candidate A is actually 0.48 that falls in our interval. So if 0.48 favor candidate A, that would mean that 0.52 would favor candidate B. So then you would have conflicting arguments here. So this person's claim is actually incorrect because it captures that 0.5 in between there and goes less than it, that we don't know exactly where this person, who's going to win this election. It can kind of go either way based on. And this is where I usually said, I made that point also, that election polls usually use the word point or points instead of percentages. So like they're leading by 9 points, which means he is ahead by 9%. And also use the margin of error as within a margin of error of 2 points, or so. In this case, he's up by 9 within 2 points. So he really could be up between 7 and 11. They're not exactly sure. That's the whole point of this confidence. We're not exactly sure, but you can kind of go from one to the other. The next thing is interpreting confidence level. So this is different than interpreting a confidence interval. Okay. So here is an example. And we'll probably do an example like this in class. But imagine this green line, 0.6 is the true proportion. Okay, we wouldn't know that in a real setting, but we're just going to say, hey, 60% is true proportion. If I did one confidence interval, this is what I would get. Okay, I'd get somewhere between like maybe 0.53 to 0.72. And based on this one interval, I would capture the confidence, the true proportion. So if I did one interval, I would say I am 95% confident that the true proportion is within the range, or I'm 95% confident. I have that here. That the interval from 0.53 to 0.72 captures the true proportion of blank. Okay. Now that's just one confidence interval. If I do this again, maybe I get this interval which also captures it. Maybe I do this one which doesn't capture it. Maybe I do another that does, and it does. I do, and I do, and I keep doing all these, right? And basically, this kind of goes with that idea of probability of large numbers, that if you do a lot of these confidence intervals, you repeat them over and over and over again, the 95% confidence level says that we would expect 95% of the confidence intervals to capture the true mean, or the true proportion. Okay, so I don't know. They say that. So if I do one interval, I can say that I'm 95% confident it captures this. But to interpret what that confidence level means, what does that 95% mean? it means that if I took a lot of samples, I'd be 95% confident that, or 97% of them would correctly identify the population parameter. So I wrote them both down here. This is what we just talked about, the interpreting a confidence interval. Okay, so from one value to the next. Interpreting a confidence level is what we would say here. If we were to select many random samples of the same size from the same population and construct in this case, 95% confidence interval using each sample, about 95% of the intervals would capture the parameter in context. So that 95% confidence interval tells me if I did a bunch of them, we'd expect 95% of them to capture the true mean or the true proportion. Okay. The AP exam tip right here, just a quick hint. You may be asked to ask for the confidence level or the confidence interval or both. So make sure you understand which are we talking about. The next subsection is interpreting a confidence level. Okay, I think we're still inside that same subsection actually, interpreting a confidence level. So this is a big hint. The confidence level does not tell us the probability of a specific confidence interval. Okay, so if I go to like this idea, if I had this confidence interval that's in yellow, again, I don't know what the true proportion is, so I don't know it's at 0.6. Here I could see, okay, we're saying it's 0.6, but in reality, I don't know if this captures the actual proportion or not. If I did a bunch of these, I would expect it to capture 95% of the time. But if I just did one, I don't know exactly if it did or if it did not. Okay. So the confidence level does not tell us it. It doesn't say like this specific interval has a 95% chance of capturing it. All we know is that 95% of all confidence intervals will capture it. Okay. So there's a little bit of a difference between the two. What we're talking about here. So the one interval. So that's why, sorry. Here, we want to avoid that kind of probability language. So we don't want to say this. We do not want to say this confidence interval captures the parameter 95% of the time. So that's not true. Okay, it either does or it doesn't. It's not 95% of the time it does. Once you make that confidence interval, it's stuck. It's here. So it either does or it doesn't. So the probability is either 0 or 1. Now we're 95% confident that it does, which means that if we took a bunch of samples, 95% of them would capture that confidence interval. Okay, so the confidence interval doesn't capture the true mean 95% of the time, but I'm 95% confident that this does. Okay, there's a chance that it doesn't. There's a chance it falls out of it, but I'm 95% confident that it does. Okay, so we have to be very, very specific with our language. And so we're in the last subsection, kind of what affects the margin of error. So up here, I have two separate confidence intervals based on the same point estimate. So my middle is the same. At the top, I have a 90% confidence interval, and at the bottom, I have a 99% confidence interval. And so at first, you might be like, wait, why is 90% smaller than 99% larger? But that should make sense, because if I want to be more confident, I need a wider interval. Think back to that country idea. How many countries are there? If I wanted to be extremely confident, I want to be 100% confident, I said 0 to 500. Well, that's a really long interval, right? To go from 0 to 500. But that gives me 100% confidence. If I wanted to maybe lose a little confidence, but to be more a smaller interval, so maybe I said it's from, what did I say? I said from 90 to 210. Now I'm a little bit smaller of an interval, but my confidence also goes down. So the smaller the interval, the less confidence I have. And think what if I didn't have an interval at all? If I just had my point estimate, then my confidence would be really, really, really tiny, but I'd be very specific. I'd have a very small interval, but I also have a very small confidence. Okay. So there's a couple ways you can decrease the margin of error. Okay. If you to decrease the confidence level decreases, obtains a smaller margin of error, and that smaller margin of error, the price of doing that is you accept less confidence. So if I want a smaller interval, I'm less confident I captured it, but I have a smaller interval to kind of work with. Another way to decrease the margin of error is to increase sample size. And we've seen this over and over again. Increasing the sample size reduces the margin of error for any fixed confidence level. So if I have that confidence level, I'm going to increase the sample size, decrease the margin of error. And this kind of has a small example. So let's just say we took another. Sorry, I got an email there. So let's say this is just another example, kind of just throwing it together. So my interval is a point estimate plus or minus the margin of error. So I can start with my point estimate, p hat, and I'm going to add or subtract this 2 times sigma p hat. So where does that come from? Well, let's think about it. Where else do we see 95% confidence or a 95%? And that goes way back to the start of the year when we were talking about the empirical rule. And we know that within 2 standard deviations, we capture 95% of the data. 1 standard deviation is 68, 2 standard deviations is 95, 3 standard deviations is 99.7. Well, if I want to capture it 95% of the time or have 95% confidence interval, I'm going to be multiplying by, I want 2 standard deviations to the right and 2 to the left. So that's exactly what we do here. We're going to kind of add and subtract by 2 times the standard deviation of that. And so if I had my p hat, I could easily find my standard deviation of p hat. It's just p hat times 1 minus p hat divided by n times 2. So that's how we would kind of build a confidence interval. We'll see this a lot more in the next section. But it's based on this idea right here. And I'll put it in blue, kind of pop a little wavy. But it's the statistic plus or minus our critical value times the standard deviation. So our standard deviation won't change. It just depends how many standard deviations we want to go. In this case, we went 2 standard deviations. Maybe we only want to go 1. Maybe we want to go 3. Maybe we want to go 4. Maybe we want to go 1.5. It kind of depends on how confident we want to be. So that's exactly what the critical value does. The critical value is a multiplier that makes the interval wide enough to capture whatever rate it was. Okay. And we'll kind of see how do we get that critical value and kind of build these a little bit more in the next section. This is just kind of another way you might kind of word it or like to read how to affect the margin of error. So the bigger the confidence level, the bigger the margin of error. So if I'm 99% confident, I'm going to have a larger margin of error than if I'm 90% confident. So another way you can say this, or the wider the interval or the looser the estimate, then the larger the margin of error. The bigger the sample size, the smaller the margin of error. And that's because we would decrease the standard deviation as we increase that sample size will decrease the standard deviation. And lastly, margin of error. This is kind of a big thing that I want you to realize. Margin of error does not account for bias, such as convenience sampling or non-response sampling, or non-response. It only accounts for sampling variability. So for example, the sample we took is not going to be exactly equal to the population proportion. And if I took a separate sample, I get a different sample. So I get a different p hat, right? So depending on the sample, kind of determines what my confidence interval is. So that margin of error is what kind of accounts for this or allows this sampling variability to happen. It doesn't account for bad sampling. So if I take a convenience sampling or I get non-response bias or whatever the case is, margin of error does not account for that. It only accounts for the difference in my type of sample. And then to finally wrap this up, one last example. As part of a project about response bias, This survey a random sample of 25 students from her school. One of the questions in the survey requires students to state their GPA aloud. Based on the response, said that 90% confidence that the interval from point 0.4 to 0.72 captures the proportion of all students at her school with GPAs greater than 3.0. Explain what would happen to the width of the interval if the confidence level were to increase to 99%. So you went from 90% to 99. So I am more confident. So if I'm more confident, I need a wider interval. So the confidence interval would be wider because I'm increasing the confidence level, and that increases the margin of error. How would the width of the interval, the width of a 90% confidence interval, based on a sample size of 100 compared to the original 9% interval, assuming the sample proportions remain the same. So we went from sampling 25 students to 100. So when you increase sample size, you would decrease the sample standard the margin of error. And so specifically, you can do a little bit of math here because they gave us the numbers from 25 samples to 100. The confidence interval would be half as wide because the sample size is 4 times as big. And you said, wait, 4 times is big, but it's half. But it's because we're taking the square root of n. So when we take the square root of times it by 4, that's really taking the square root of 4, which is equal to 2. So we've halved it or made it smaller by half, even though we've increased it by 4 times. And lastly, describe one potential source of bias in this study that is not accounted for in the margin of error. So depending on what you said, you could just say the margin of error does not account for the fact that many students might lie about their GPA when having to respond without and I can never say this word, anonymity, uh, being anonymous. The proportion of students in the GPAs greater than 3.0 might be less than 0.4 because again, we'd expect people to lie to say that it's higher than it actually is. All right. So that's it for 8.1, everyone.